Hello guys, welcome back. Now in this session we are going to discuss about another kind of distribution plot, that is box plot. So let's look into the diagram. How does this box plot look like? So this is the diagram of the box plot. So guys, box plot are a great way to visualize the distribution within the given data set. With the help of box plot, you can easily identify the quartile and interquartile information of the given data set. If you don't know about the quartile and interquartile, I have already covered this in earlier part of this course, that is learn data analysis from scratch. So if you look into this course, then you will find that at part 2 we are having descriptive statistic concepts, and where I have discussed about the measures of variability, and within that I have discussed about the quartile and interquartile range and their significance. So if you haven't gone through it, you can go through it. That would be really very helpful for data analysis. Now let's proceed further. So over here in this plot, what we are observing the mileage by vehicle class. But this time we are using the box plot, and over here each box is the representation of the vehicle class, that is compact, mid-size, SUVs, two-seater class, minivan, pickup, subcomponent. And if you closely look into this box, then you will find that it has some long line on top of each of the boxes. So this means that this kind of data, for example subcompact class variation, exists within the range from 18 to 35. The another thing which you have observed over here, we are having a line within the box. So you must be asking that what is the significance of that particular line. So that line represents the quartile information, more specifically interquartile range. So guys, one thing you should remember, that whenever you want to visualize the distribution of the data and you want to visualize the median, 25th, 75th quartile along with the outliers, then box plot is very useful. But there is a problem with the box plot, is that sometimes size of the box will mislead you. As if you see over here in this two plot, both are having different kind of data, then you will find that the box size is same even though the observation number is different. The orange box contains 47 number of cases and blue box is containing the 5 number of cases. So why is it so? That is because their statistic matching even though their number of cases is varying. So what it means? So it means that their 25th percentile, 75th percentile, their median value is matching. So that's the reason it is showing the similar size, as box plot is used to visualize the distribution in terms of their statistic. I wanted to tell you one more thing. Over here you will find that we are printing the observation so that we will give the complete information about the data distribution. Suppose if you are giving this information without these observation information printed on each box, then other person will think that both the boxes contains the same number of cases in the given data set, and that kind of interpretation mislead the data analysis. So it is recommended that whenever you are using the box plot, it would be always good practice to specify the number of observation within the box. So now let's proceed to the Jupyter notebook and write the code for box plot. So we are into the Jupyter notebook, and the steps which we are going to follow is similar to the earlier one. Step 1 is for global setting, which I have already completed. Step 2 for importing the data set, and we are going to import the same data set which we have been following from the last 2-3 sessions, and over here that is mpg.csv. Preparation of the data is not required for this particular plot, so I haven't touched this step. At step 4 I am going to write the code, but over here if you closely look into our diagram, then you will find that we have printed these number of observation on each of the boxes. So to print these values, this method will help us. I have already created this one, and it is pretty much a straightforward function which accepts 3 information. One is the data frame, another one is the column name on which we are drawing the box plot, and the third one is the target variable. Over here it is highway, and once we get the information, we are creating the median dictionary, and then we are calculating the x-tick levels, and then we are identifying the number of observation or number of cases in each of the categories of vehicle class, and then we are printing it into the each boxes. So now let's start writing the code to draw the plot. So as usual, we are going to follow the same pattern. We need to create the plot figure, and here we need to specify the same, and I am going to specify figure size equal to, we can keep it the same specification which we have been following, dpi equal to 80. And to draw the box plot, we are going to use C1 method that is called box plot, and over here we need to specify that at x-axis what we want to keep, and there is a class variable which I have already shown you. If you want to see it again, let's print this one first run the step 1, and for step 2 print df will print us the data frame. Over here you will find that we have a class variable, and that is what I am going to use it over here. I want to print at x-axis, it will represent the class, and then at y-axis I want the highway mileage information, and this is our y-axis highway. Then we need to specify that the data which I want to keep is the data frame which we have created over here. So this is the data frame. Once it is being done, then we need to specify there is something called notch equal to false. So this will create the box plot. So once it is being created, we need to print the observation on each box. So what I mean to say that, so these number I want to print it. Now I will call the method which I have already been created, and where I need to pass the data frame as well as the two variables which we are plotting over here, like class and the highway. So let's do it. So I will call this method. So I will tell that add underscore n underscore obs, and within that I am going to specify I want to pass data frame df group call equal to class. This is our variable, and the y I am telling that highway. So that's it. So this will put the text, that is number of observation, on each box. Now we are done with this step. Now let's decorate it. So to do the decoration, I'm going to specify the title. So I will tell plot title, and this is our box plot. So I will tell box plot of highway mileage by vehicle class. So once it is being done, I need to specify the font size, that is large, as you know that this is a constant which I have declared at top. Now next I need to specify that the y limit. So I want y lim should be in range of 10 to 40. So I will specify 10 to 40, and at last I will tell plot.show. So we are done with the plotting. So now cut this code and paste it over here. So now let's run it and see the output, what output we are going to get. Do shift enter, and then you will find that we got the same plot which we have seen in the diagram. For this particular example, we are identifying the distribution of the highway mileage by vehicle class. So this is what this plot is representing over here, which we have already discussed earlier, and this is what I wanted to demonstrate you in this session. So guys, in our next session we will be starting with the another type of plot, that is for composition. So in this aspect we are going to learn about pie chart, tree map and bar chart. So on this note I am stopping over here. See you in the next session. Till then, bye bye, take care.